Hey guys, welcome back to the Career Guide Academy. Let's start with the today's third lecture of electrostatic, in which we are going to learn about the Coulomb's law in vector form, superposition theorem and some numericals based on them. So before starting to the Coulomb's law in vector form, I would like to request you that you should revise the vector chapter a little bit so that you will come to know what is unit vectors and how to represent the vectors graphically. Okay, so let's begin. So Coulomb's law, already we have learned about the Coulomb's law. Whenever we want to tell about the forces between the two charges, then we are using the Coulomb's law, right? So Coulomb's law states that the force between the two charges are directly proportional to the product of the charges and inversely proportional to the square of the distance between them, that we learned in the last classes. So in vector form, whenever we want to learn about the Coulomb's law in vector form, we have to know that two statements regarding this. So if I want to tell about the force, so force is vector quantity. Force is vector quantity. So in last class, whatever we have learned, that is the magnitude of the force. That is the magnitude of the force. So force means some magnitude, and as well as we have to represent its direction also. So we have to represent direction. So vector form of Coulomb's law is based on the direction, right, which will lead us to show or represent the force direction. So for direction, we have to remember the two statements. So first statement is that the force will always acts along the line joining the two centers of the charges. This is the first thing that we should remember while representing the direction. Second thing, what we should remember, second thing is, already we have studied that positive charges will repel each other, as well as negative charges will also repel each other. But you can say positive negative or negative positive, that is unlike charges, will always attract each other. So basically, if we have knowledge of these two things, the Coulomb's law in vector form is finished. Yeah. So how we are going to use this statement to represent the force direction? So let's consider Q and Q are the two positive charges, right? So the force of Coulomb's force between them will be a repulsive force. As it is repulsive force, if we consider only the Q charge, that is small q charge, what this capital Q charge is going to do? It is going to repel it, means it is going to push it. So if it is going to push, so it can push it in this direction, it can push it in this direction, or it can push it in this direction. So all these three are the pushing directions. So in which direction it is going to push? For that purpose, we require the first statement. The force will be always acts along the line joining the two centers of the charges. So what we have to do? First of all, we have to draw the line which is joining the two charges. So this will be the horizontal line which is joining the two charges over here. So our force must act along this direction, and it must be repulsive. It must be repulsive, means on this charge it has to be towards right direction. So we can say this is the force which is acting on small q due to the capital Q charge over here. So basically we have used these two statements, and what we have done, we have found the magnitude as well as direction of the Coulomb's force. So magnitude already we have studied, that magnitude will be equals to K Q divided by R square. But what about direction? Direction we got that it will be always along the line joining the two centers of the charges, and as two charges are positive charges, both are like charges, so they will repel each other, and this force should be towards right direction as shown in figure. Now what about this capital Q charge? Yes, on this capital Q charge also same force is going to act, because same charges are there and same distance between them is there. So what is going to happen on this charge, whatever force is going to be there, it will be always along the line again, but it must be repulsive. So you can think about this charge. What this charge is going to do, it is going to push this charge towards the left side, means on this charge the force should be left side direction. Means if we consider the two charges now, on the two charges same amount of force is acting, but their directions are opposite, right? So this we have represent the forces in diagram, right? In diagram we have represented. Okay, now if I want to tell mathematically how we can represent the forces, mathematically we want to represent their directions also, and here vectors comes. Okay, so let's see how we can write these forces mathematically in vector form. Okay, let's consider this capital charge is at certain location, and that location will represent by number 1, right? And the small q charge is at the location 2, right? Let us consider we have 2 points now where 2 charges are located, 1 and 2. So for timing we will call the force F that is on 1 due to 2. So we can say F12 force in vector form that we have to represent. Here we will say force on 2 due to 1 now, right? So these are the two forces which are going to act on these two charges as of now, right? Okay, so magnitude we have told in equation, or we can say mathematically we can be able to calculate, but what about the direction, right? So to know the directions we will just revise little bit about the vectors. So let's represent these 2 points on x y axis graphically, right? So this is y axis, this is x axis, this is point 1 and this is point 2. So if I want to tell the position of 1 with respect to origin, let us say this is the origin. So how we can represent the 1, that is by a vector starting from 0 or origin towards the position 1, starting from origin towards the position 1. And for 2 we can say it is towards the 2 from the origin O, right? So these two are the position vectors. So let's represent them by R1 and R2. So these two are the position vector of 1 and position vector of 2, but we don't want this direction. We want the direction that is F21 means towards right over here, or you can say from 1 to 2 over here, and the another which is towards left means from 2 to 1 over here. So how to represent that direction? We have to join this line, means whatever directions we are talking about now, that should be along this line, either from 1 towards 2 or from 2 towards 1. So let's assume we are going to take the direction from 1 towards 2, or we can say up to 2 from 1. So let's represent it by R21. Direction I am saying R21, or you can say the vector R21, which is going to represent the direction from 1 towards 2, or we can say up to 2 from 1. Why we are writing up to 2 from 1? That is the logic which we learn in the vectors, where we have learned the triangle, law of triangle, in which we have considered if there is a triangle and two vectors are in same direction. So we can write R1 bar plus R21 bar. So their addition will be represented by third side of that triangle, and which is in opposite sense. So these are, you can say, almost clockwise, and this is anti-clockwise for them. So this will represent the resultant of these two. So I can get it is like this one, right? So basically if I want to find out R21 bar vector, that R21 bar vector will be equals to R2 bar minus R1 bar. Basically in this case we are getting R2 bar first, then R1 bar, means the position of 2 with respect to 1, that's why we are writing like this, the position of 2 with respect to 1, means we are standing on 1 and we are watching towards 2. So this will be the direction, we are standing on 1 and we are watching towards the 2, that will be the direction, means this R21 bar vector is in the direction from 1 towards 2, means we are standing on 1, we are watching towards 2. So this is the vector, but we don't want vector. What we want? We just want direction, because magnitude of force we have got. We just want its direction, right? So direction means what? We already learned in vectors, that is direction is nothing but the unit vector. Direction is nothing but the unit vector. So R21 bar is the vector, and if I find what is the R21, what is the unit vector along the R21 bar, then our work is over. So what I am saying, if we consider the R21 bar vector and if I find the direction, or you can say if I find the unit vector along this R21 bar, that is nothing but mathematically representation of the direction. So unit vector we need to find out. So unit vector means what? We can say that unit vector along R21 bar, that we can be represented at, that can be represented as R21 cap. So we can get, it will be equals to R21 bar divided by its magnitude, or you can say just the distance, So this thing we are going to take into account while representing the force now, right? So if mathematically I want to represent the force, then I have to write its magnitude and I have to represent its direction. So magnitude we have written over here. So I have to just add the direction. So if I want to write force in vector form, right? So Q by R square is the magnitude, right? But I want to represent its direction now, and I know that direction can be represented by unit vector. So unit vector from 1 towards 2, that will be equals to R from 2 to 1, from 1 towards 2, or you can say up to 2 from 1, or you can say with respect to 1. Position of 2 with respect to 1. So the vector we have to take, but it should be a unit vector which is going to represent only the direction. So magnitude of force cannot be affected, only direction will be represented. So what we can say, R21, if I am writing here, it means the distance is R21 and the direction is up to 2 from 1, right? Now if I want to represent, let us say from this logic, if I want to represent the direction opposite from 2 towards 1. So if I want to write direction of 1 with respect to 2, that will be equals to R1 bar minus R2 bar, right? So if I want to represent this R12, it will be just opposite to the if I want to represent the R12, now it will be just opposite, or you can say it will be just negative of this. So we can write this will be equals to minus of R21 bar. What it means, if I want to show the direction of this, I can show the direction by the vector, means we are watching from 2 towards 1, means 1, position of 1 with respect to 2, direction means we have to consider the unit vector, or we can write this as R21 cap, but it will be right side direction, so make it opposite, I have to write the negative sign. So both are equal. We can show magnitude, but direction either I can write R12 cap, or we can write minus R R21 cap. Here also same thing we can apply. We can write R21 cap or we can write minus R12 cap. So hope you would have understood this Coulomb's law in vector form. So we have to represent the magnitude that we already learned in scalar form of Coulombs. Then direction is important, that already we learn how to logically tell the directions by considering the two statements. So once we are able to find out graphically what is the direction, mathematically we have to just write the unit vector along that direction, right? So this is about the Coulomb's law in vector form.